Welcome back to Python Scripting for GIS Applications, a class at the University of Alaska Fairbanks, and this is spring semester 2013. In this video session, I'm going to teach you how to count features associated with other features. So for example, here we have one line representing a stream, and in this simple example, we've got points representing fish locations. And just to keep it as a simple example, I've got two species, burbot and grayling. And you can count along this line, there are 4 burbot locations near the line, and there's 4 grayling locations near the line. And in this example, I say near the line because they're not exactly on the line. So for example, if we zoom in on this burbot, it is off the line a little bit. So what we need to do in our Python scripting is we'll have a search tolerance. As long as the point is within 5 meters of the line, we're going to count it as being on the line. Okay, so what we want to do is write a Python script that will summarize how many points are on each line by some attribute. So in this case, by fish species. And here we've got points, and in the point attribute table, there's a name field that's basically a text field, and it contains the value that's a string, either grayling or burbot. Okay, so how do we do this in a Python script? Okay, so as always, what we'll do is we'll import the OGR module, and then we'll make a driver for Esri Shapefiles. And then we'll open our stream shapefile. And in this case, there's no reason to open it with write access. So we'll open it with read-only access, which is a code of 0. And that way we can't accidentally delete that shapefile. And then we'll call our line layer from our data source. So then we'll make this line layer object, which is our stream. So once again, this is a very simple example. We've got one stream. In the homework assignment, you'll have many streams. Okay, so then what we'll do is open our points shapefile. Once again, a code of 0 because we're not going to write to this shapefile, and we don't want to accidentally delete it in our Python script. And then we'll call our layer from that shapefile points layer. Okay, so what we're going to do is have a list that will be our counter, and that list will count for each species the total number as we process these points that are near the line. So I'll call that list fish counts. You could call it anything you want, and we're going to initialize it. So it will be 0 and 0. So the idea here is we've got, when we start, 0 grayling would be index our first item, and then 0 burbot will be our next item. So in a real-life application, you might have this list indexed to 20 different items on the list if you had 20 different fish species in your point shapefile. Okay, so if you remember, our points was just a point and then a text field with a name, and the name either contains grayling or burbot. So the trick is we'll make a dictionary that will return a key value associated with those names. And you could call that dictionary anything you want. I'll call it lookup. So the idea here is we grab a point and then we get the name field. And if that name field contains this value, we're going to look up this key value 0. So then it would tell us that this is the counter associated with that point. And if we get a point and we get the field that's the name field and it contains burbot, then we know that that's in index 1. So that is this counter value. So once again, this could be for 20 species instead of 2. And let me do Alt-P to recall my previous command. And this dictionary actually should be lookup. And then I'll do a little house cleaning. I'll get rid of that old misspelled list. Okay, so now we've got this dictionary. And in this simple example, it's just going to have 2 items and 2 key fields that we're going to look up. Okay, so then we'll get our stream feature. So in this case, we only have 1 line, and that's going to be index 0 for that 1 line. And then we'll grab its shape field, and we'll return that shape field into a geometry object, and I'll call it streamline. Okay, and if you remember in this simple example, our points are not on our line, but our points are within 5 meters of the line. So what we'll do is we'll say, okay, we'll make a little buffer, and that buffer will be 5 meters from the line. So if the point's within 5 meters of the line, we're going to consider it to be associated with that stream. So then what we'll do is we'll make our spatial filter from this stream buffer. So basically, any point that's within 5 meters of the line will be considered a selected point. So then we'll simply loop through all the selected points that are inside that stream buffer. So loop through all the points that are inside that stream buffer. So get one of the selected points, and then grab that field that contains the name of the species, and then we'll put that in a variable. Okay, so now we've grabbed for that point the species name, and it's going to be either grayling or it's either going to be burbot. So then we could use our dictionary and grab either a key value of 0 or a key value of 1. And I'll return that key value into a variable, and I'll call it L. You could call it anything you want. So basically L is going to be 0 if the point has a name grayling. It's going to be 1 if the point has a name burbot. And then we simply accumulate in our list our count. So say, for example, our first selected point is burbot. So here we apply our dictionary and say, okay, our species name is burbot, so get the key value for burbot. And the key value for burbot is a value of 1. So fish count index 1 is equal to its original value, which was initialized at 0, plus 1. So after we execute that, the counter in this location will be 0 plus 1, or 1. And then we just execute our loop. Okay, so now we've got our list of fish counts. So let's see if it correctly counted all those points within 5 meters of the stream. And it did. So the first item in our list, index 0, is for grayling. And then the second item in the list, index 1, is for burbot. So you can see how this would work. If we had 20 fish species, it would be the same exact idea. And then we would simply print out to the user how many grayling were counted within 5 meters of the stream and how many burbot were counted within 5 meters of the stream. So there's 4 grayling near the stream, and burbot. There's 4 burbot associated with that stream. Okay, so for this week's assignment, if you go to the NRM 638 website, I've got a more complex example for you where there's many salmon streams and different salmon species associated with these salmon streams.